In this lesson, you're going to learn how to add and subtract rational expressions that already have common denominators. Let's take a look at some examples. Now, these are just regular fractions like you've learned previously, and we're just going to review how you can add fractions with common denominators because this will relate to today's lesson. So if you look at the first problem, 1/6 plus 1/6, remember you can add fractions as long as their denominators are the same. And just recall, to add, we're going to add the numerators, but keep our denominator the same. And then, of course, if we can, we'll reduce it to lowest terms. And in the second example, the same thing. And this time we're going to subtract. But to subtract fractions, again, the denominators must be the same. And what we're actually subtracting are the numerators. And 5 minus 2 is 3. And again, at the end, we're going to look if we can reduce. And if we can, we're going to go ahead and do that. Now, we want to understand this because it's going to relate to adding and subtracting rational expressions. And in this particular lesson, our rational expressions will have common denominators such as these. So look at this first problem, 5x over 2x plus x minus 5 over 2x. Notice the denominators are the same. So just like in the previous slide, whatever the denominator is, we'll just slide over. It will not change. And then what we're going to do is we're going to add our numerators together. So we have 5x plus x minus 5. Now we want to look in the numerator for any like terms. And notice that we have 5x and 1x. So we can go ahead and add those together, and that will give us 6x, and then we'll just bring over the minus 5. Now, if you look in the numerator, there's no further factoring that can be done to 6x minus 5, and because the denominator is a monomial and the numerator is a binomial, there's nothing more we can do to simplify this problem, so we would be done. So again, in order to add these, the denominators must be the same. You must have common denominators, and what you're actually adding are just the terms in the numerator. Let's go ahead and move on to this example. In this example, once again, the denominators are the same. So because we have a common denominator, we can just slide that denominator over. Now you need to be careful when you have a subtraction sign, especially if a binomial follows it. Let's actually write it out, 4 minus, and whenever you have a binomial, especially in the numerator, put it in parentheses. Now, because of the minus sign, it's like having a -1, so you actually have to distribute that to each term in the binomial. So I'm going to bring over the 4, and then -1 times x is -1x. And then -1 times 4 is -4. So you have to make sure and distribute that negative to both terms. Now, if we continue to look in the numerator, we're going to look for like terms. We have a 4 and a -4 that are like terms, and if you add that together, it becomes 0. So we're going to eliminate those, leaving us with -1x, or just -x in the numerator. And then we'll just bring over the denominator. Now, because the binomial in the denominator cannot be factored any further, and because you have a monomial in the numerator, you are done. You can't do anything further to simplify this. Okay, in this next problem, which is a subtraction problem again, notice we have matching denominators. So again, we're going to go ahead and bring that over. And then we're going to combine the numerator together. Again, we're going to look at the sign, and it's a subtraction sign, and we're going to put any binomials in parentheses. So what we have is 4x minus 3x minus 2. Now we're going to distribute that negative, which will change the sign of the 3x and the -2. So the 3x will become positive, the 3x will become negative, and the 2 positive. From here, we're going to combine the like terms in the numerator. So we're going to combine the 4x and the -3x. So 4x minus 3x is going to be 1x, or just x. Now, This time we have a binomial in the numerator, which we can't do anything further with at this moment, but we have a trinomial in the denominator. So with trinomials, there's always that possibility, if you factor it, that one of the factors will also be a matching binomial. So let's go ahead over on the side here to the left, and we're going to actually factor this, or see if we can, to see if it will allow us to do any further simplifying. So if we factor this, we're going to look for numbers that have a product of -6, but a sum of our middle number, which is -1. So we'll start out with a product of -6. So we have all of these combinations over to the left. And we're going to see if we have any combination that has a sum of -1. And we do. So let's go ahead and fill in our binomials. From there, we're going to transfer over those binomials. So now we have x plus 2 over x plus 2, x minus 3. And notice we have matching binomials in the numerator and the denominator. So those will cancel. Now remember, the x minus 3 is in the denominator, so it needs to stay in the denominator. And we're just going to fill in the numerator with a 1. So it'll be 1 over x minus 3. And that completes the lesson on adding and subtracting rational expressions with common denominators.